Coming up on today's episode. Welcome back everyone to the DERB workshop. I am Doug, your host. This is a little bit different than what we've worked on the last couple of videos. I wanted something that was a little bit different as far as what kind of problems this had. You may recall from the assessment of this or evaluation that this unit had distorted audio on one channel. Almost to the point where it was no audio, but it was present, just very badly distorted. And as such, I thought that would be an electronic fix, as opposed to the last two, which were mostly mechanical fixes. The Radio Shack one with the tape door problems that had to be fixed that way, and JCPenney had cassette belt just basically disintegrated. And, you know, mostly there was no electronics required for that. It was just mainly hardware type stuff that had to be fixed. So I thought this might be a little change of pace and get to use the signal tracer on this. And I think that's going to be fun to do. First thing up I'm going to do is take the cabinet off. I've already looked at the bottom. It has the same sort of setup as the Radio Shack clarinet had. It has screws that go through to the chassis and hold the chassis in, and once there's a removed, this should just slide out. And we can put the cabinet aside and get to the meat of the matter, which is going to be the amplifier. So let us get to that and see what's happening. Alright, one of the quick things I want to note here is these missing things here. These are the feet. There's two on this end here. If we look up above, we can see there's also two up here. So those are where the rubber feet should be mounted. Obviously they are missing. So those will have to be on the lookout for as far as replacements. I think I have some, but I don't know if they're the right size. We'll have to wait and see, I guess. But anywho, that's I just want to point that out while I had this up like this. Okay, what we can see now that we have the cabinet apart, or out of the cabinet, however you want to say it. This unit is divided into several different sections, I guess is the best way to put it. We have the radio section, I believe, right here, as you can see. Let's get down here a little bit so you can see it. Right here, there's the AM antenna, there's the tuning wheel, tuning string. You can see all that attached to this board here. So that obviously is the radio itself. Now, from what I can see, this is a switch, something to do, I believe, with the tape. So I'm going to say that might be something to do with the tape. And of course, obviously, above that is the tape, the 8-track tape player. And you can see, obviously, also, you may recall from my assessment that tape head was very loose in there. And that will need to be fixed. And so we'll be right back to the mechanical fixes. Finally, our amplifier board is here. You can see here's the outputs, all four of them. Those are usually heat sinked in some way so that they, you know, because they get warm from being audio outputs. And so it's pretty simple looking amplifier, left and right channel. Obviously, we'll go to the volume control and check that out first and see exactly what we have and where the distortion starts and ends and things like that. If I had to guess, and I don't really want to guess, but if I had to guess, problems with the audio like that, like we heard, are with the final transistors. Probably one of them blown or open or something of that sort, and that's just my assessment as far as my experience goes. So, you know, we don't know for sure, but it could be. So the only way of finding out is to actually get out the signal tracer and start signal tracing this and seeing exactly what is what. So let's get to that and we'll be right back. Alright, well, we are back once more. What I've got going here is, this is the right channel of the amplifier. Now this is the good channel, this is the one that works, and what you can see on the scope, the top yellow line is the input signal, and the bottom yellow or blue line is the output. And we'll vary it a little bit so you can see it go up and down. There's down and there's up. As you can see, that's the volume control, and that waveform there looks pretty darn good. I am not very good with this scope yet because it's really the first time I've played around with it that much, and I was just trying to basically capture the waveforms on a USB stick and do that, and every time I hit run stop I get that, but that's not what I want. I want the single thing, and if I hit single I get that and it keeps saying wait. I don't know what I'm waiting for basically. So anyway, like I said, it just doesn't seem to want to capture it. I don't know if I haven't got a high enough signal in there or what. I'm going to have to do some reading on this to figure this out. But again, you can see without doing all that. I hit run again, and you can see the difference in the signal. And you can also see the signal shape is pretty consistent. It is a pretty good sine wave, both the input and output. And so there you go. That's a good look at that one. Now what we're going to do is split. We're going to switch off to the left channel, and I'm not going to change any settings other than just put the probe up on the left channel and see what happens there. Yeah, there you go. That's a pretty good image there. Now that's not bad, but you can see clearly there I'm going to put it on stop. And now you can see again, like I said, that's the difference in the waveforms. Now again, the top one is looking like it's the same level, but it's not really, because I have one. Well, no, come to think of it, they're both set on ×1. So actually, it probably is the same level. But again, it's not up that much, not even halfway up, and I've got the balance in the middle. So. Again, so there you go. There's your good look at the. At least I got a good capture of the waveforms, and that was really what I was trying to do. So you can see a little bit of a flatness in the top one, but again, overall, it's not a bad one. Nothing near like the bottom trace. You can see there's a very definite distortion in that. So that's what we're looking to get out of this, and I hope that I've made that clear now. And again, I apologize for all the bumbling that I've done, but again, this is all new to me as far as how to use this thing. And I've looked for some good tutorials on YouTube on this particular scope, but I haven't been able to find any because I guess it's so new or whatever. But basically, like I said, it is pretty good. It is pretty good little scope, and like I said, it makes it easy. Now I should be able to put a stick in there, a USB stick, and get that image captured. And I really haven't figured that out yet either. Once I get that figured, I'll be able to use this and illustrate things a lot better. But for right now, it gets our point across. You can see the distortion clearly in that waveform over that waveform, and so. That's pretty good, I think. Let's see if I can get this down a little bit. Let's go down to the bottom one, channel 2, and go up. You can see a little bit of difference there, but like I said, that has a lot to do with the channel 2 and channel 1 settings. What kind of millivolt settings were they on and things like that. When you put it in auto, you really don't know. It's listed here somewhere, I'm sure, but again, it's hard to tell for me because now you can see on the display on the bottom. Let's see if we can get down there a little bit. Frequency on the yellow is 1 kilohertz, and that's what it's supposed to be. frequency on the blue is 992, it looks like. So yeah, they're pretty close. Same frequency and everything. So that's, you know, good indication that that's working. So again, that's going to do me on this. So I'm going to do some other explanations here on this, and we'll get right back to you on that. So hang on. Okay, what I was getting at before this came up, or what I got to do with the scope, I wanted to point out that this is the inputs here, and I don't know which one's which, but you have a blue here and a red here, but these are the inputs to the amplifier itself. Now all the switching is done in the front panel there, all your stuff like that. You got your function switch there, switches from one FM to auxiliary to phono, whatever it's doing, and then all that is fed into here, whatever switched in. So that's the input itself to the amplifier. Now yesterday when I did this, I had the scope on one side of this and I had the output on the other one, and it was very clear. You could see the input was just perfectly clear on this, no distortion at all on either input, and the output on one channel, the left channel, was clearly distorted as you saw in the waveforms. So what we're going to be doing here today, or not today, but what we're going to be doing here is to basically go through this and see if we can't basically separate. Now there's a pretty good, well defined dividing line here, this ground strip right in the middle of it. So you can pretty much assume that anything on that side is one amplifier and anything on this side is the other, because you remember this is stereo. So all your outputs are on this side here. 1, 2, 3, 4 right there. And so all of the circuitry in here is how you would get from here to the outputs and to out your speakers. So basically we're going to try to track this down, and there's, like I said, several transistors in this area. I don't know, audio stages, I guess is what you would call them. I was going to point out also that basically when we look at this, when you see a capacitor, you can think pretty much signal path or signal conditioning. The resistors are usually voltage related. They are dropping resistors and things like that. They are used in signals, dropping the strength of signals, but mainly for the B plus type voltages, and that's what they are used for. Now that's not to say that one of those is not causing our problem, but when tracing down the path here, we want to basically come in here, go to the next stage, check the input and output to that transistor, and then if that checks out okay, go to the next one and vary, and so on and so on and so on until you get to the outputs. Now I'm not really sure about the outputs, because the only thing I've checked that with so far is the signal tracer itself, and again, if you remember, the sound wasn't that much different. That's why it was so difficult to get that different sound, and that's why I decided to go with the scope instead, because you can see the distortion right on the scope, whereas the hearing sometimes plays tricks on you. You don't really hear, especially when you're using a 1,000 hertz tone or 400, any kind of tone. When you hear that, it has a lot to do with that. So. But anyway, like I said, you can easily see it on the scope. You can see the difference, and we should be able to find a point here on one side or the other, and I don't know which is which, to tell you the truth. I haven't really traced anything down, but on one side or the other that is clearly distorted compared to the other side. Well, any side, it doesn't matter. It should be a perfect sine wave coming out, just like it is going in, if everything is working correctly. So. It should just be amplified. So that's the deal on that. And what I plan on doing on this is to take a picture of the back side of this, and I'm going to try to get as many of these wires out of the way as I can. That's not going to be totally easy, but if I can do that, and then take a picture of the other side and overlay them and see if I can get the a picture using opacity and things like that on the pictures, and see if I can't get an overlay to find out how these are connected. In other words, what traces go to what transistors, etc., etc. And that will make our whole tracking down here a lot much easier. I'm just not talking today very good, so I'm not doing a lot of things good today. I don't know. But anyway, like I said, it is that's the way that works, and that's what we're going to be doing. And again, I'd like to get a full path, at least of one amplifier. Once you can do that, you can pretty much go back to the other side and check out the same path and go that route. So that's the plan anyway. And what I may do on this, and it's looking more and more like it, because I'd like to have some kind of clear path to look at instead of just going in there willy-nilly and checking this, checking that. And you know, when you do that, you can't be guaranteed on what you're checking. And so I'd like to get a clear path of how the signal flows through there, so that we can just instantly go to the top side then, and you know, go to this transistor or that capacitor or whatever, and see in an instant what kind of signal we have there. So that's the plan anyway, and we'll get back to it. But again, as I started to say, this may be a two-parter, because what I'd like to do is take my time on this and explain it as best as possible, help others understand, hopefully. I mean, you know, this is my way of doing things. I understand that, but again, this usually will get the job done. So that's usually a good thing. So, but like I said, if you can, because you know, one of the reasons I wanted to do this, because we don't have a schematic for this, and it's not impossible to trace things down without a schematic. As long as you know how the signal flows through any circuit, you can pretty much troubleshoot it and figure out what the problem is, even not knowing all of the different parameters. So again, it's not the end of the line when you work on something without a schematic, and it really makes it a good practice to get into, to try to do things without a schematic, and that way you get good at identifying, you know, signal paths and what should be there and what shouldn't be there and things like that. So anyway, I know I've talked enough. I'm blah, blah, blah. So let me get off here, and again, we will get back to this when we get back to it, but I want to get that those circuit traces pictures taken and get that all done, and then we will go from there. So, all right, I'm back again. As you can see in front of you there on the screen, that is the bottom of our amp circuit board, as seen earlier on earlier clips. I'll point out this again. This is one input here, this white wire here. This white wire here is another input. So you have two different channels there for the stereo. And I'm going to show you here in a minute, all this stuff up above, basically this line here, is power supply related. In other words, the rectification and filtering for the main power supply is done up on this board as well. And I'm going to show you the cutoff point. We're going to look at this in just a minute. Now I'm going to show you the top side. And what I did first was to get these basically in the same shape, size I should say, and made sure that they were as close as I could get them to vertical, and you know, the same way. And now on this one I took and mirrored it, because the outputs were on this side when you looked at it, because that's how you take a picture of it. You look at it that way. But for our purposes, we wanted it mirrored, because the outputs, as you could see, I think on the other one, outputs are on this side here, and this is the input side here, as we just went over. So that's what I did there. So our input is basically here and here, or here and here. I'm not really sure which it is, but one or the other. It is, like I said, I think it's these two capacitors here. But I'm going to overlay this now. What I did also was to take one of these and invert it. I think it was the bottom one that I inverted, and I'm going to show you that picture just here next, as soon as we can bring it up here. Alright, well there you can see the overlay that I did. Now again, I made one of them inverted colors so it would stand out a little better. You can basically see the traces here coming in, and traces here and traces here. But this is, like I said, the one I wanted to show you. There is a cutoff point here. I don't have it drawn out as I thought I did. I must have gotten rid of that, but I did have it all basically cut off here and a line drawn there, so you can make sure that you never see everything past this point on this end. You can see is a mirror image of each other. In other words, these two capacitors here mirror these two. This one mirrors this one. These two mirror this one. These two mirror each other, and these two mirror each other. So that's what you have. You have two stereo. This is the dividing line again. That was that ground path going all the way through there, as you recall from that one image. And so these are our stereo amplifiers. Our outputs are here. Here's one set right here, and here's the other set right here. So, like I said, this should be easy enough to do. What I'm going to try to do is take one or the other, it doesn't really matter, and follow this the best I can using the scope and the transistors involved, where I think there's two transistors here. I think there's one. I thought there was two here. Maybe that was one. But I think I'm pretty sure there's two transistors on each circuit besides the outputs for each one. There's two of the outputs on each one, so there's four altogether. So I'm going to try to trace the in and out of those and see which ones are basically clear. And we may even have to go all the way over to the outputs to get our, it may be the outputs. I don't know. I can't really tell right now as it is or not, but a lot of times these outputs are what usually goes distorted. Again, one of them gets open or something like that. You don't have half your push-pull or whatever it is, and like I say, that's what usually happens. So that's what we're going to do, though. I just thought I would explain that. We're using the aid of this board that I've overlaid. I thought it come out pretty darn good. You can see perfectly where these traces go to, and like I say, that's a ground trace there. There's a ground trace there, and again, I can always reference the actual traces picture, and if I need to get an exact estimate of where these are hooked up to. I think even this is you can see the emitter base and collector and things like that on the transistor, and so that should be very helpful, I think, in tracing this thing out. So, all right, I'm not going to talk so much here. What I'm going to do is we're going to call this part 1, and we're going to actually get into the rest of the diagnosis with the scope in part 2. And once we find the bad section, bad transistor, bad capacitor, bad resistor, whatever it turns out to be, we'll replace that and do our test. So stay tuned for that, and you guys have a great day. Thank you so very much for watching, and we will see ya.